Hello friends, in this video, I'll teach you how to take Z transformation for finite length sequence as well as infinite length sequence along with their ROCs. Let us begin. Let's start with Z transformation for finite length sequence. The reason why they are called as finite length sequence because as the name implied, length of the sequence is finite. For example, in a very first case, if you count number of samples, how many samples are there? 1, 2, 3. It means 3 is the length of x1 of n. So length of x1 of n is how much? It is 3. So basically it shows the number of samples present in a given discrete signal. If number of samples in a given discrete signal is finite in number, in that case the respective signal is called as a finite length sequence. Similarly, for x2 of n, as you can see, the length of sequence is again 3. And last, in x3 of n also, the length of sequence is 5. So length of sequence is nothing but number of samples present in that respective signal. Like for third, as you can see, there are 1, 2, 3, 4, 5. Since there are total 5 samples, so n equal to 5. That is a length of sequence. I'm sure now you are convinced the reason why they are called as finite length sequence. Since now you have understood this, let us try to get Z transformation for individual signal along with their respective ROC. Let's start with a very first signal, that is x1 of n. So x1 of n, which is given to me, it is 1, 2, 4, and the arrow mark is shown here. This arrow mark indicates n equal to 0 position. So let us write the formula of x of z, which is summation n equal to minus infinity to infinity x of n z to the power minus n. Now, as you can see, the n is varied over minus infinity to infinity, and if I do so, and if I expand this summation, then it will have total infinite term. That is, all negative values of n are covered along with all positive values of n along with n equal to 0 also. So what I'll do over here is, let's say expand this n values and let me vary n from minus 1. So for example, when n is equal to minus 1, it will become x of minus 1 z to the power 1 plus x of 0 z to the power 0. So here the value of n is equal to minus 1, here n value is equal to 0. Now all rest of the n values will be positive. Let's say n equal to 1, then it will be x of 1 z to the power minus 1, then we will have x of 2 z to the power minus 2, and then it will also go up to infinity. Of course, before this we will have term, let's say x of minus 2 z to the power 2. Is that right? In this case, if you look at x1 of n, then, and if you actually show a graphical representation, then at x of 0, that is x of n at n equal to 0, there is a signal having amplitude equal to 1. This is at n equal to 0. At n equal to 1, it is having amplitude equal to 2. And finally at n equal to 2, it is having amplitude equal to minus 4. Since it is minus 4, then I must draw it here like this. This is a graphical representation of the given signal x1 of n. So this 1 is nothing but x of 0. This 2 is nothing but x of 1. And finally minus 4 is nothing but x of 2. What is meant by x of 0? X of 0 means x of n at n equal to 0. What is meant by x of 1? X of 1 means x of n at n equal to 1. And finally, x of 2 is nothing but x of n at n equal to 2. Since our signal is starting with only 0, then x of minus 1, I'll take 0. This is 0. So this term has gone. So what is the value of x of 0? It is 1. So I'll substitute 1 here. What is x of 1? X of 1 value is 2. What is x of 2? X of 2 value is what? It is minus 4. And rest, all of the terms are equal to 0. Let us substitute value and let us get x of z. Finally, x of z can be taken as, the value of x of 0 is 1 and z to the power 0 is also 1. So first term will be 1 plus x of 1 value is 2, z to the power minus 1 plus x of 2 value is minus 4. So I must make this sign as minus 4. So minus 4 times z to the power minus 2, and this becomes x of z. I'm sure you understood this problem. This is what we called as z transformation for finite length sequence. Now let's talk about ROC now. I can rewrite this x of z as 1 plus 2 into z inverse, means it is 2 by z, minus 4, and z to the power minus 2 can be written as 1 upon z square. I hope you understand this. You know what? We basically get mod of z value in such a way that x of z has to be finite. So x of z has to be finite. So now you can take any value of z and you can see to it that x of z is always finite. So whatever values of z you are taking, you have to make sure that x of z has to be always finite. So can you tell me a particular value of z which you should avoid so that x of z doesn't become infinite? I repeat, can you tell me some value of z, if I substitute in this x of z expression, will make x of z to be infinite? Then the answer is yes, we know such value. If you substitute z equal to 0, x of z will become infinity. I repeat, suppose if you substitute z equal to 0 in this expression, x of z will become infinity. Now the question is it desirable or undesirable? Of course, it is undesirable. So will you prefer to substitute z equal to 0 or will you avoid to substitute z equal to 0? Of course, we will avoid z equal to 0 value. It means you can substitute the value of z as anything but not equal to 0. Even though if you substitute z equal to infinity, that is not going to matter, because z, once you substitute equal to infinity, it would be 1 upon infinity, which will result into 0. Even this z square becomes infinity, so 1 upon infinity becomes 0. In a way, you will get x of z value equal to 1 even though z tends to infinity. So in this expression, if you want your x of z to be finite, your mod of z should not be equal to what? 0. Or you can write this way, mod of z should be greater than 0. Is that right? Or you can write this way, ROC is entire z plane except mod of z equal to 0. So this is the definition for ROC for the given signal. I hope you are clear with that. So x1 of n, as you could see, it was a finite length sequence. We know that this arrow mark indicates n equal to 0 position. This is n equal to 1 position, n equal to 2 position. By default, your summation starts with minus infinity and ends at infinity. Then you can actually modify this formula and you can write your x of z this way. That is, x of z is equal to summation. Your signal is varying from 0 to 2. So lower limit you can take n equal to 0 and upper limit you can take 2 x of n z to the power minus n. And after that you can expand it like this, x of z is equal to, substitute n equal to 0, it will give you x of 0, z to the power 0 is 1, plus when you substitute n equal to 1, it is x of 1, z to the power minus 1, and last value x of 2, z to the power minus 2. And then just substitute the value of x of 0, x of 1 and x of 2 and get the final answer. Observing x of z, you have to see that z should be in such a way that x of z should be finite. So you have to always choose a value which makes x of z to be infinite. And then you have to say that you have to avoid that particular value if you want your x of z to be finite always. So in a way, we have found out ROC this way. So I would say the nature of x1 of n signal, it was a right-handed signal, that is, the value of x of n signal in such a way that the signal is always 0 for all negative values of n. So I would say this is a right-handed signal. So nature of x1 of n, let me write it, then I'll come to the final conclusion. So x1 of n signal is, I would say, it is a right-handed signal, and to be very precise, it is a causal signal. So it is a causal signal and a finite length. So causal signal and a finite length. Let us start with the second signal. So x2 of n given as 5, 4 and minus 2. Let me write formula. If you want x2 of z or in general x of z, let me write for x of z, summation n equal to minus infinity to infinity x of n z to the power minus n. Is that right? But here n cannot be varied from minus infinity to infinity because our sequence of the length is finite. That is, this arrow mark indicates this is present at n equal to 0. Then the sample which is prior to n equal to 0 is present at n equal to minus 1, and this is present at n equal to minus 2. So as you can see, your signal starts with n equal to minus 2, ends with 0. So lower limit is minus 2, upper limit is 0. So let me modify our formula. Therefore, now x2 of z can be written as summation. Now n can be varied from minus 2 to 0 only. Instead of x of n, I'll write x2 of n z to the power minus n. Now let me expand it. First of all, I'll substitute n value equal to minus 2. It will become x2 of minus n, or x2 of minus 2 rather, z square plus x2 of minus 1 z to the power minus 1 plus x2 of 0 z to the power 0. Now this is equal to, let us substitute x2 of minus 2 value. What is x2 of minus 2 value? It is 5 times z square. Am I right? Then what is the value of x2 of minus 1? x2 of minus 1 is 4. So it is plus 4 z to the power, has to be plus 1. So z to the power 1 plus x2 of 0 is nothing but minus 2. So it will be minus 2, and z to the power 0 will become 1. Finally, what I have is 5z square plus 4z minus 2. And this is your x2 of z. So finally, x2 of z is known to me, but what is not known to me is the ROC. So now you keep on substituting any value of z in x2 of z, I'm sure you will always get some finite answer. So now you can say that x2 of z equal to 5z square plus 4z minus 2 can have any value of z, because for any value of z you will always see x2 of z is always finite. But then if you think carefully, you will come to know that z cannot be infinity, because the moment you substitute z equal to infinity, what is going to happen? x2 of z will become infinite. You really want your x2 of z to be finite or infinite? Of course, it has to be finite. Then which value of z to be avoided? Then I would say it is infinity. Then I can comment that ROC is entire z plane except z equal to infinity. Or you can say that mod of z can be anywhere between 0, but it should be less than infinity. Or you can just simply write mod of z should be less than infinity. So it is going to cover all other values other than infinity. This is how we have decided ROC of our signal. So before I go to the next problem, let me write the nature of x2 of n. So nature of x2 of n is, it is a left-sided signal. It is also called as anti-causal signal with finite length. Let us go for the last sum, that is finite length sequence. So x3 of n, it is provided as 1, 2, 5, 4 and 3, and the arrow mark is given at 5, meaning that x3 of n at n equal to 0 having amplitude equal to 5. So let me see, this is x of 0, this is x of 1, this is x of 2. Then the value which is prior to x of 0 will be naturally x of minus 1, and this is x of minus 2. So as you can see, the lower limit is minus 2, upper limit is 2. Let me just write my x3 of z formula. So x3 of z is summation n equal to minus 2 to plus 2 x3 of 2, or x3 of n rather, z to the power minus n. Now I can write as x3 of minus 2 z square plus x3 of minus 1 z to the power minus 1 plus x3 of 0 z to the power 0 plus x3 of 1 z to the power 1 plus x3 of 2 z square. So this is the upper limit we have substituted now. Look at the value of x3 of minus 2. It is 1. then it is simply z square. x3 of minus 1 is 2. I would say 2 z to the power 1. This has to be positive 1, plus the value of x3 of 0 is 5. So it is simply 5. Z to the power 0 is what? 1. Then x3 of minus 1, in fact x3 of 1 is minus 4. I suppose to say minus 4 times z has to be negative, z to the power minus 1, and x3 of 2 is nothing but 3, then it is plus 3 times z to the power minus 2. Finally you can write this as z square plus 2z plus 5 minus 4 by z plus 3 by z square. As you can see, the z has gone in denominator. It means z shouldn't be 0, otherwise the x3 of z will become infinity. Also, z is present in numerator also. It means z shouldn't be even infinity also. What does that mean? Mod of z should lie between 0 and infinity. It means mod of z should not be equal to 0 also, and mod of z should not be infinity also. Either of them will make x3 of z to be infinite, which is undesirable. So this is the ROC information for x3 of z, or I can have my ROC in other words. ROC is entire z plane except mod of z equal to 0 and mod of z equal to infinity. So avoiding these two values, mod of z can be anything so as to keep x3 of z to be finite, because the whole aim was x3 of z to make it finite only. And let's see what is the nature of the signal. As you could see, the signal is present at left hand side also, and signal is present at right hand side also, meaning that the given function is a both sided function, and we know that the both sided function is known as non-causal function. So this is a non-causal sequence. So this is what? A non-causal and finite length. Is that right? So let me come to a final conclusion. The sequence given, that is nothing but a discrete time sequence given, can be of two types. The one can be finite, the other one can be infinite. Infinite sequence we will discuss later on. First of all, let us discuss finite. In finite, you had three cases. It can be causal, it can be anti-causal, and third, it can be non-causal. Am I right? Now, let's talk about causal sequence. You know what? Causal sequence are those sequence which are completely right-handed signals. In completely right-handed signal, if you see x of z, they will always have negative powers of z. So if you see the causal sequence x of z, your x of z contain negative powers of z. If you see anti-causal sequence, which is purely left-handed side signal, here x of z contains positive powers of z. And if you look at non-causal, non-causal being it is left-sided also and right-sided also, then it will have negative powers of z as well as positive powers of z. Is that right? And you know what? This gives me a clue about ROC. So as I said, we will discuss this infinite length of sequence after this topic. Let us concentrate on the finite length sequence. So for causal sequence, you know that all n values are positive, but we know that in the formula we have z to the power minus n. So all n values being positive, z to the power minus n makes it negative power. In anti-causal, we know that it is completely left-handed signal, means for all values of n to be negative, but in the formula we have z to the power minus n, and since n is negative, they become all positive powers of z. And when it comes to non-causal, you don't have to worry about it, whether it is n equal to positive or n equal to negative, since they are present on both the sides, right hand side also and left hand side also. At right hand side, n values are positive, then z to the power minus n makes negative powers of z. Whereas it has some sequence present at left hand side also, that is for negative values of n. Then if it is negative values of n, then z to the power minus n makes positive powers of z. So non-causal sequence, it has positive powers of z as well as negative powers of z. So as I said, this negative powers of z will have z inverse or z to the power minus 2. So I can rewrite this as 1 by z, 1 by z square. Such term you will find in first case, that is causal case. Is that right? Then which value of z you avoid in order to make x of z to be finite, or you avoid to make your x of z as infinite? Then we should say that then mod of z should not be infinity. Then I would say that mod of z should not be 0, or I would say mod of z has to be greater than 0 always. When it comes to anti-causal sequence, you will always have positive powers of z, so you will always find your x of z equipped with z or z square or z cube, etc. Such terms you will find in second case. In that case, your mod of z should be always less than infinity. I mean, your mod of z should not be equal to infinity in order to make x of z to be infinite. And when it comes to non-causal, it has positive powers of z and negative powers of z. Then it is actually combination of causal and anti-causal together. Then you should actually avoid 0 also, infinity also. Therefore, your mod of z will lie between 0 and infinity. That is, so mod of z should be greater than 0 and mod of z should be less than infinity. And you can club this together. That is, mod of z should be greater than 0 but less than infinity. Or we say that it is entire z plane except 0 except infinity. Here ROC is entire z plane except z equal to infinity, and in this case I can say it is ROC having entire z plane except z equal to 0. I'm sure now you are quite comfortable with z transform of finite length sequence. Let us start with infinite length sequence. So these are some infinite length sequence. Let me tell you about infinite length sequence. See, for example, I'm talking about u of n. What is u of n? U of n is nothing but a step signal having amplitude equal to 1 at n equal to 0, n equal to 1, n equal to 2, that is all positive values of n. For all negative values of n, u of n value is always 0. So we know the graphical representation of it. But suppose if I want to write it in terms of sequence, we write it this way. That is, it is 1, 1, 1, 1, and this is never ending, right? This is never ending. And we show an arrow mark here. It indicates u of n at n equal to 0, it is 1, and n equal to 0 onwards, it is always 1. But for n negative, it is always 0. And suppose if I want to count the number of sequence in order to get n, that is length of sequence, then it will tend to infinity, because we cannot actually count the number of sequence because number of sequences are infinity, and such sequences are called as infinite length sequence. So whenever in your x of n expression you find this term u of n in any form, that is u of n, u of minus n, or u of minus n minus 1, or u of minus n minus 2, or u of minus n minus 3. Basically, if you find any form of u of n, you just understand that it has to be a infinite length sequence. At least 90% of the time it will satisfy this criteria, that it will be a infinite length sequence. And how to handle with infinite length sequence, this is now what our lookout is. Let's start with the very first problem, that is 2 to the power n u of n. Let me remind you, for u of n, it is given as 1 upon 1 minus z inverse, or it is also written as z upon z minus 1. You write it in any form, it doesn't matter, but mod of z has to be greater than 1. So this was the z transform for u of n, am I right? You know that by shifting theorem, that is first shifting theorem, if it is a to the power n u of n, in that case a z transform would be, then as I said, that for a to the power n x of n, it is actually x of z by a. So what we do is we just replace z with z by a everywhere, am I right? So in this case you can tell me it is 2 to the power n u of n. So I'm going to treat this u of n as x of n, and value of a will be equal to what? 2. Then how to go about it? It is 1 upon 1 minus c. What I have over here is z inverse, but instead of z I supposed to substitute z as z by a. then I would say it is z by 2 inverse, or I can write this as 1 upon 1 minus 2z inverse. Am I right? Similarly, even in this case, it was ROC was mod of z greater than 1, but every time we have to replace z with z by a, and a value is 2, then I would say mod of z by 2 is greater than 1, and now you can shift 2 there and you can say mod of z greater than 2. Is that right? So let me conclude something. See, if it is, let's say, u of n, then what is the z transform? Z transform is 1 upon 1 minus z inverse, where mod of z is greater than 1. I hope you understood this. For example, if it is a to the power n u of n, then what do you do? Just replace z with z by a. Then it will become 1 upon 1 minus az inverse, where mod of every time z has to be replaced with z by a, then it will be z by a greater than 1. Then I would say mod of z greater than mod of a. This is ROC. Then what was given to us is 2 to the power n u of n. Then it will have z transform as 1 upon 1 minus value of a is 2, then it will be 2z inverse, where mod of z is greater than 2, or you can say mod of 2 also, it doesn't matter. So let me draw the ROC structure. As you know that mod of z is nothing but r, and r is nothing but radius, and when I'm saying radius, it is radius of the circle. So radius of the circle with radius equal to 2 and mod of z greater than 2, it means ROC will be outside z equal to 2 circle. So this is the ROC for 2 to the power n u of n. I'm sure you understood this. So if you want, I can just explain this once again. See, u of n has z transform as 1 upon 1 minus z inverse, where mod of z greater than 1 is the ROC. Now let's say you have a to the power n u of n. Then what you are actually doing, you are replacing z with z by a. Then it will be 1 upon 1 minus z is replaced with z by a, and this is whole inverse, and z is again replaced with z by a greater than 1. Then this is equal to 1 upon, so it is z by a inverse, then it will become obviously az inverse. So 1 minus az inverse, where mod of z, this a is shifted to right hand side, it is mod of a, or you can just simply write mod of z greater than a. So in our case, the value of a was equal to what? 2. Am I right? Now let me write the nature of the signal. It is 2 to the power n u of n. Please tell me, when something which is multiplied with u of n, you know that u of n is purely right-handed signal. Therefore, I would say this is a causal sequence. Causal and infinite sequence. So this is causal as well as infinite length sequence. I require it when I'll come to the conclusion. First of all, I'll make sure that I'll solve all the problems, and then I'll get back to all the problems and I'll take a final conclusion which will give you a clear insight. In fact, once we get to the conclusion, you don't have to really fight for ROC every time. You will be in a position that you will just observe it and you will get the final answer. Let's solve the next problem. So second problem says it is minus 1 by 3 to the power n u of n. So we know that a to the power n u of n has z transform as 1 upon 1 minus a z inverse, where mod of z is greater than a. This is the formula. I'll take this as a standard formula now. Now it is minus 1 by 3 to the power n u of n. Then it will have z transform as 1 upon 1. We have negative sign here, but value of a is negative. Then it will become 1 plus 1 by 3 z inverse, where mod of z will be greater than a. But what is the value of a? It is minus 1 by 3. Am I right? Or I can write mod of z to be greater than 1 by 3. So people get wondered why it is not still greater than only minus 1 by 3. Why you are making it positive 1 by 3? Let me tell you. Please don't forget, mod of z is nothing but r, and r stands for radius, and radius cannot be negative. So we always take a magnitude of the number whatever we get in ROC. And if I want to draw the ROC, it would be like this. So I'll draw a circle here, and you have to show the area which is outside the circle, am I right? Then this is your ROC. And nature of signal, again, since it is multiplied with u of n, of course it has to be a causal and infinite length. One more thing, if I want to get a pole for this, how do we get a pole for this? I'll tell you. See, your x of z, answer was 1 upon 1 plus 1 by 3 z inverse, am I right? Now let's say if I'm multiplying numerator and denominator with z, it will give me like this, z upon z plus 1 by 3. And by equating denominator to 0, it gives me pole. So pole is present at minus 1 by 3. So minus 1 by 3 I can take over here. This is a pole location. And I could do this in the last problem also. Just pay attention. So this was our x of z, am I right? This was our x of z. So x of z was 1 upon 1 minus 2z inverse. Now if I multiply and divide by z, it will be z upon z minus 2. And if I equate denominator to 0, I must get a pole, and pole is equal to what? 2. If it is positive 2, then I must make it over here. Please remember, when I'm saying it is a z plane, then it also has a real axis and imaginary axis. This is a real part of z, and this is imaginary part of z. Is that right? So when I'm saying it is z equal to 2, then it is a positive real number, then I must mark it over here, because I knew that this is the circle with radius equal to 2. So this is the circle with radius equal to 2. Third problem, it is 2 to the power n u of n plus minus 1 by 3 n u of n. And now as you can see, it is actually combination of question 1 and question 2 together. So we directly know the z transform for this. It is what? It is 1 upon 1 minus 2z inverse with ROC mod of z greater than 2. And we know answer for this also. It is 1 upon 1 plus 1 by 3 z inverse with ROC mod of z greater than 1 by 3. And we have plus sign in between, so I must give a plus operator here, because I'm just using a linearity property here, am I right? So whenever there is a linear combination of signals together, output will be a linear combination of individual z transform. So let me talk about this ROC. ROC number 1, R1, is mod of z greater than 2, and ROC2 is nothing but mod of z greater than 1 by 3. We have already seen such cases where we get multiple ROCs. So whenever there is a linear combination, for every term we get individual ROC, but then we have to take a common ROC, and that common ROC is nothing but R1 intersection with R2. Then what is a common ROC? So this claims it is greater than 2, this claims it is greater than 3. In order to satisfy both, I'll select this ROC, because if I take this ROC, when I say mod of z greater than 2, it satisfies greater than 1 by 3 also. So common ROC is nothing but R1 intersection with R2. In this case, it is mod of z greater than, is that right? So here they are talking about two radius. That is, first radius is having radius equal to 1 by 3. The other radius is having magnitude equal to 2. Am I right? So this is having radius equal to 2. This is having the radius equal to 1 by 3. So there are two circles over here, and the ROC is mod of z greater than 2. That is outside z equal to 2 circle. So this is the ROC area. That is mod of z greater than 2. And where are the poles? Then by modifying this expression little bit, I'll get z upon z minus 2. And by modifying this, I'll get z upon z plus 1 by 3. So as you can see, one pole is present at positive 2, the other pole is present at minus 1 by 3. So minus 1 by 3 is one pole and plus 2 is the other pole, because minus 1 by 3 means it is a negative real and positive 2 is a positive real. So accordingly, I have plotted the poles also. Now, let me come to some shortcuts. Just pay attention what I'm trying to convey you. I'm using shortcut in order to get ROC directly. So just pay attention to what I'm saying. In case if required, you can just note it down what I'm trying to tell you. First point, whenever you are multiplying a particular function with u of n, most probably it is going to become infinite length sequence, and that could be a right-handed sequence. Secondly, the ROC will always have a greater relation because there is a presence of u of n, which makes it a causal sequence. I repeat, presence of causal sequence is just because there is a presence of u of n, and whenever there is a presence of u of n, then ROC will always have a greater relation, and you know that ROCs are bounded by what? Poles. Then what is required? Poles are required. Let me tell you very clearly. Here poles are directly given. Just observe. This is a pole and this is also a pole. See, one pole was present at 2, the other pole was present at -1 by 3. And this is applicable for every problem you will see. Let's go back over here. See, this is a direct pole, that is -1 by 3. As you could see, -1 by 3 was the pole. In the last problem, 2 to the power n, then this is a pole. So as you could see, this 2 was a pole. So let me tell you, see, let's say you have 2 to the power n u of n. Am I right? So I don't have to take Z transform. Let's say what is asked to me in the exam is only ROC. Then I'm not going for Z transform. So I know that this 2 is nothing but the value of pole. Then mod of Z. Since there is a presence of u of n, it will always have a greater relation. Then mod of Z greater than 2 is direct a ROC. For example, you have, let's say, -1 by 3 raised to n u of n. Then we know that -1 by 3 is nothing but a pole location. And due to presence of u of n again, since it is a causal function, mod of z will be always greater with respect to the radius. And what is the radius of the circle? It is -1 by 3 or +1 by 3. Of course it is +1 by 3. See, this -1 by 3 is nothing but a pole location. But since radius cannot be negative, I'm taking mod of this -1 by 3. Similarly, when you had a combination of these two, that is 2 to the power n times u of n plus -1 by 3 n u of n, then you had two ROCs, mod of z greater than 2, mod of z greater than 1 by 3. Then please remember that you have to always take the outermost point or outermost circle. That is, here I'm taking one circle of radius 2 and ROC is outside or ROC is outward. Please remember, presence of u of n makes ROC outward. Presence of u of n again makes ROC outward. That is, here we are going to draw a circle of radius 1 by 3 with pole present at -1 by 3, and again ROC is outward because there is a presence of u of n. Is that right? Here there are two poles, one pole at 2, the other pole at -1 by 3. So there are two circles, the one which is associated with -1 by 3 pole and the other circle present at 2. I'm sorry if they are not looking like circles. So here, since there is a presence of u of n, ROC nature will be always outside the circle. In case if you have two circles, then you have to take the rightmost circle and then you have to shade the particular portion. In this way, you can remember as a shortcut to get the ROC. If you remember, in Laplace transformation also we have learned those shortcuts. If you remember, the presence of u of t, in continuous time signal I'm talking about Laplace transformation particularly. The presence of u of t makes the function causal. If you remember, similarly u of n in case of discrete time signal makes the function causal. In case of causal signal, now I'm talking about Laplace transformation, the nature of ROC was rightward. And in case of Z transformation, we are going to show the ROC in the form of circles or with respect to circles, then ROC is outward. So you can just remember rightward for Laplace and outward for Z transform. Let's move ahead with the next example. So fourth example is 2 raised to n u of n plus minus 1 by 3 raised to n u of n plus minus 4 raised to n u of n. Now my question is, I'll get my Z transform later on, but can you directly answer me the ROC? Then it is very easy. We know that ROCs are bounded by poles. So what is required, the pole location. So definitely the first pole is present at 2, the other pole is present at 1 by 3, and the remaining pole present at 4. So there are how many circles? 3 circles, because every pole will have its own circle. So there are 3 circles. First circle with radius 1 by 3, the other circle with radius equal to 2, and one more circle with radius equal to 4. And now where exactly poles are located with. So you can see that the first pole is present at minus 1 by 3, the other pole located at positive 2, and one more pole is there present at minus 4. Is that right? Now tell me, we have 3 circles and everywhere there is a presence of u of n. So this is the combination of causal signals together. So linear combination of causal signal together gives you causal signal only. And ultimately, since you have a final signal as a causal signal, of course it will have ROC as outward nature. And when there are multiple poles, that is multiple circles, you have to always select the outermost circle. So what is the outmost circle? The outmost circle refers to the circle with radius equal to 4. Then of course ROC will be outside 4. Or you can write mod of z greater than 4 as ROC. I'm sure you understood this, because from the first term what we have ROC as mod of z greater than 2. In second case, again it will be mod of z greater than 1 by 3. Even though it is minus 1 by 3 present over here, radius cannot be negative. Please remember that. And finally you have mod of z greater than 4. And if you take a common ROC, it will be mod of z greater than 4, because mod of z greater than 4 satisfies greater than 2 also, greater than 1 by 3 also, and greater by 4. Of course it is going to satisfy. And if you want to write their Z transform, you can write it this way. You know that a to the power n u of n has a Z transform as 1 upon 1 minus a z inverse. Let us refer to this formula and write Z transform directly. So x of z is now, tell me, a very first term 2 to the power n u of n will have Laplace transform as 1 upon 1 minus 2z inverse plus 1 upon minus 1 by 3 raised to n u of n, then it will become 1 plus 1 by 3 z inverse. The reason why we have plus here, because minus 1 by 3 is there, plus 1 upon, again we have minus 4, then it will be 1 upon 1 plus 4z inverse. And this is a final Z transform and ROC that you have already learned. Let's move to the fifth problem. So fifth problem belongs to 2 raised to n u of minus n minus 1. You know that if u of n, I say it is a right-handed signal, u of minus n minus 1, we have already learned it is a complement of u of n. And what is complement of u of n? It is u of minus n minus 1. If u of n, I say it is right-handed, then u of minus n minus 1 will become left-handed signal. Then this is a left-handed signal. And we know that all left-handed signal belongs to anti-causal function. And please remember that when it comes to anti-causal function, then mod of z will always have a lesser relation with respect to ROC. Please remember, whenever I say a causal function, mod of z you will always find greater. That is, ROC is outside the circle. But now you will have ROC inside the circle if it is an anti-causal function. That is a left-handed signal. In that case, we have already seen this, that is a to the power n u of minus n minus 1 has a Z transform as minus of 1 upon 1 minus az inverse. As you could see, it is having similar form, 1 upon 1 minus az inverse. Only thing is there is inclusion of negative sign here. And secondly, mod of z will have lesser relation with a. I hope you understood this. In this case, it is 2 raised to n u of minus n minus 1. Then it will have Z transform as minus of 1 upon 1 minus 2z inverse, where mod of z will be smaller than 2. Is that right? Then if I want to draw this, I'll have a circle with radius equal to 2. And where the pole is present? Again, the same theory, the pole is present at 2. And then ROC is inside the circle. So please don't forget, this is the real part of z, and this axis refers to imaginary part of z. And ROC is inside the circle. This is the shaded portion which shows ROC for this sum. So you will always find that anti-causal function will always have ROC inward. ROC outward when causal function, ROC inward when it is not causal, that is anti-causal. Let's move to the sixth problem. So it is 2 to the power n u of minus n minus 1 plus 4 to the power n u of minus n minus 1 and minus 1 by 3 raised to n u of minus n minus 1. So as you can see, each and every function stated over here is multiplied with u of minus n minus 1, and we know that u of minus n minus 1 makes it anti-causal. And now this is a linear combination of individual anti-causal signal. Then the final product, that is a final sum, is anti-causal in nature. And if it is anti-causal in nature, we know that the nature of ROC is always inward. So here I'm just going to get ROC directly. So first pole location is at 2, second pole location at 4, and third pole location at minus 1 by 3. Then we will have 3 circles of 1 by 3 radius, 2 radius, and 4 as a radius. So we'll have 3 circles. So here mod of z will have lesser relation with respect to radius is 2. Here mod of z will be lesser than 4, and here mod of z will be lesser than 1 by 3. Then we have to take a common ROC. So what is the common ROC? Of course, common ROC, I must go for mod of z 1 by 3, because if I select mod of z 1 by 3, it is going to satisfy that if mod of z is less than 1 by 3, it will be less than 2 also, and it will be less than 4 also. Therefore, we are selecting this as the ROC, that is mod of z less than 1 by 3. And of course, whenever it is a linear combination, that is R1 ROC, R2 ROC, and R3 ROC, our duty is to take R1 intersection with R2 with intersection with R3, and that gives you a common ROC. So we can draw, in fact. So 3 circles are associated. Circle 1 with radius 1 by 3, circle 2 radius with radius 2, and circle 3 with radius 4. Now the question is where the poles are present. In first case, the value of pole is 1 by 3. In fact, it is minus 1 by 3. I must say minus 1 by 3 here. Next radius is 2, positive 2, and last radius is positive 4. So this way we can show the radius. And where the ROC is present, final ROC is inside 1 by 3 radius circle. Therefore, we can make this as a shaded portion. Indicates mod of z less than 1 by 3 as our final ROC. And it is very easy to write their respective z transform also. 2 raised to n u of minus n minus 1 will give me minus of 1 upon 1 minus 2z inverse. I'm sure you know how do we write this. Let me remind you, a to the power n u of minus n minus 1 will have z transform. By default, negative sign come over here. 1 upon 1 minus a z inverse, where mod of z less than a was our standard form. Then again we have positive, then it will be negative. It is 1 upon 1 minus 4z inverse. Am I right? Then we have again positive sign here, then it will be positive. But since z transform is negative, this positive will get converted into negative. It will be negative of 1 upon 1. Since it is minus 1 by 3, it will become plus 1 by 3 z inverse. Am I right? And this is its final z transform. Let us solve the last problem. It is 1 by 3 mod of n. So it is minus 1 by 2 raised to n u of n. So let us understand the signal first, because until and unless the proper signal is not known to you, you cannot go for Z transformation, and also you cannot get ROC. So let's try to figure it out what that a very first term says. Let us try to decode this. In this you will find only one unusual term, that is mod of n. Let me tell you about mod of n. In fact, we have already studied about mod of t. Same concept is applicable here. Just pay attention how to interpret mod of n. So mod of n interpreted like this. For example, if you take n greater than or equal to 0, please understand this duration is very important. For n greater than or equal to 0, replace mod of n with positive value of n. Secondly, for n less than 0, treat mod of n as minus n. I hope the point is clear. See, mod of n should be interpreted in two different intervals. For n greater than or equal to 0, replace mod of n with positive n. Secondly, for n less than 0, replace mod of n with minus n. Let us do this. 1 by 3 mod of n will have value. So for two intervals I'm going to define, for n greater than or equal to 0 and for n less than 0. So what is the value at n greater than or equal to 0? Then it will be 1 by 3 to the power mod of n, but mod of n should be treated as positive n, then it will be 1 by 3 to the power n. And for n less than 0, it will be 1 by 3 to the power minus n, because mod of n should be replaced with minus n. Then it is 1 by 3 to the power minus n for n less than 0. So now I can write my 1 by 3 to the power mod of n. See, for n greater than or equal to 0, it is having value as 1 by 3 to the power positive n. And this is valid only for n greater than or equal to 0. Do we know some function which is present only at n greater than or equal to 0, and even though I mention over here, it is not going to change the value? Answer is yes, I know such function. I'll multiply this with u of n. How does that matter? Please tell me. Even though I include u of n here, it is not going to affect the value, because within the duration from n greater than or equal to 0, u of n value is always 1. So can I say that it is going to remain 1 by 3 to the power n only? Of course yes. Plus, now I'm going to include this, that is 1 by 3 to the power minus n. But this is present only for n less than 0. Do we know some function, even though I include over here, it is not going to matter? Yes, it is u of minus n minus 1, because we know that u of minus n minus 1 is present only for n less than 0. In fact, from minus infinity to minus 1 it is present, and otherwise it is 0, because within this duration, that is n less than 0, the value of u of minus n minus 1 is always what? It is 1. So it is going to remain 1 by 3 to the power minus n. So whenever you have such signal, it is actually known as an umbrella signal in discrete domain. You have to expand it this way. So let me now expand my question properly. The question was, it is 1 by 3 mod of n minus 1 by 2 raised to n u of n. So we have expanded this way, that is 1 by 3 to the power n u of n plus, so 1 by 3 to the power minus n can be written as 3 to the power n u of minus n minus 1. I hope you understood this. See, it is 1 by 3 to the power minus n, then I made it 3 to the power n, it is one and the same thing, multiplied by u of minus n minus 1, I have stated over here. And we have this term also, that is minus 1 by 2 to the power n u of n. Am I right? Now, you know what? I can write the Z transform directly for this. See? You have to refer to the standard formula, a to the power n u of n. It is 1 upon 1 minus 1 by 3 Z inverse. Am I right? Plus. Now, since there is a presence of u of minus n minus 1, then we will have default negative sign here. So we need to modify this plus to minus. So it is minus 1 upon 1 minus 3 Z inverse. Is that right? Because value of a raised to n. So a value is 3 here. Now we have negative sign here. Let me put negative sign here. presence of u of n, so it is 1 upon simply 1 minus 1 by 2 z inverse. Am I right? So this is the final z transform. Now I want their individual ROC so as to get the final ROC. So presence of u of n here, then mod of z will have a greater relation with 1 by 3, because 1 by 3 is what? It is a radius. Then here, presence of u of minus n minus 1 will have mod of z lesser relation with respect to radius. So mod of z will be lesser than 3 here. And here, since presence of u of n, mod of z will have a greater relation with the radius, it is 1 by 2. So we have three ROCs here: greater than 1 by 3, less than 3, and greater by 1 by 2. Let me write them again. So what are possible ROCs is mod of z greater than 1 by 3, mod of z greater than 1 by 2, and mod of z greater than 3. Please try to understand this. I want to select a common ROC. Then I can actually club this together, and I can say finally, if I take mod of z greater than 1 by 2, it is going to satisfy both. Because if mod of z greater than 1 by 2, definitely it is greater than 1 by 3 also. And mod of z should be less than 3. This wasn't greater than 3, it was less than 3. Now the question is, can I club this together? Of course, because it says mod of z should be greater than 1 by 2, but at the same time it should be less than 3. So mod of z should be greater than 1 by 2, but it should be less than 3, and this is considered as common ROC. Like we have already learned in Laplace transformation that if the common ROC is present, then only I can say that the Laplace transform is valid. Similarly, for particular x of z, if you get a common ROC, then only I would say that x of z does exist. For example, if you get some x of z result, but if you don't get common ROC, in that case you will say that z transform for a given function does not exist. So this is a common ROC. So here I can draw it this way. So as you could see, even there are three radius or three circles. Circle 1 with 1 by 3 radius, circle 2 with 1 by 2 radius, and circle 3 with 3 as radius. Is that right? And your ROC is lying between greater than 1 by 2 and less than 3. So let me tell you, the first circle is having radius equal to 1 by 3. Second circle is having radius equal to what? 1 by 2. And the last circle is having radius as 3. And we have to see the ROC between 1 by 2 and 3. Therefore, ROC will be a common area between two circles that is greater than 1 by 2, that is outside 1 by 2 but inside 3. Then it would be this area. So this is a common area, or it is considered as a common ROC present. Is that right? So this is first time it has happened that it is neither outside the circle nor it is inside the circle. It is between two circles. Then it is considered as a non-causal function. This is considered as a non-causal function. It is neither inward nor it is outward. It is between two circles. Then it is considered as a non-causal function. Why I'm saying it is a non-causal function? Because you know that a non-causal function is actually a both-sided signal. If you remember, it was like this. It is 1 by 3 raised to n u of n plus it was 3 raised to n u of minus n minus 1, and we had one more term, that is 1 by 2 raised to n u of n. Now tell me, presence of u of n tells it is right-handed, presence of u of minus 1 indicates it is left-handed, and again presence of u of n, it is right-handed. So right-handed signal plus left-handed signal, combination of it will become a both-sided signal. So in a way it becomes a both-sided signal. And you know that a both-sided signal is said to be a non-causal function. So whenever there is a non-causal function, you will always find ROC trapped between two circles. If it is a causal function, you will always see ROC outside the circle. If you find anti-causal function, you will always find the ROC inside the circle. Let me write the final conclusion, then I'll conclude this lecture. So ROC nature is outward, that is outside the circle. For anti-causal function, ROC is said to be inward. And for both sided signal like non-causal signal, you will always see that ROC between two circles. And again, we should know the fact that ROC never include the pole, but yes, they are bounded by the poles. Thank you.